Continue on with chapter 7. We're going to now look at precipitation reactions. Basically, precipitation reactions are reactions that form precipitate. Okay, not too complicated so far, right? Well, basically what we're going to do is we're going to mix two ionic compounds, okay? And then we're going to switch the cations and the anions. And then we will check the products to see if any of them are insoluble. If they're insoluble, they precipitate, and you put an S for solid next to it. Let's look at an example. So let's take here, we're going to take 2 potassium iodide aqueous, and we're going to mix the potassium iodide solution with a lead nitrate solution. Aqueous, okay? So here we have 2 ionic compounds, right? Again, remember, metal and non-metal. Metal is first, non-metal is second. The non-metal is the anion, the metal is the cation. Positive, negative. Remember that, okay? So positive, negative, positive, negative. So we're going to switch these. We're going to put the potassium with the nitrate. Everything has to be balanced. This is already balanced, right? There's 2 potassiums, there's 2 nitrates. So you write down 2 KNO3, and we'll check to see if that is soluble or insoluble. We'll check our chart in a moment. Then, taking the iodine and the lead, okay? Now there's 2 iodines, there's 1 lead. What's the charge in the lead? If you don't remember, it has variable charge. There's 2 nitrates. The charge of the nitrate is -1. Thus, the charge of the Pb has to be 2 plus. Okay? 2 plus. What's the charge on an iodine? It's a halogen, right? So it's -1. Well, there's 2 of them. So 2 halogens per lead atom. Now, do not write IPb. The metal goes first. Okay? Remember this stuff, right? PbI2. Right? Again, charge of 2 plus. Charge of each one of those is -1. Potassium, again, charge +1, -1. Right? So again, switch cations and anions, making sure you're balanced. Now, we need to check these on our chart, right? Well, you might remember, nitrate was on the first chart, soluble. There are no exceptions. So all of them are soluble. So this is going to be aqueous. What about lead iodide? You check iodine. Iodine also is normally soluble, but check the exceptions. You check the exceptions, Pb2 plus is one of the exceptions, meaning that it's going to be insoluble. Again, looking at your chart. So this is going to be a solid. Again, that does not stand for soluble, that stands for solid. The PbI2 precipitated is what happened. Now, I'd say if you have any questions, yeah, but I don't know, email me. We'll do another problem. Let's check out another one. Right, again, this one's balanced also, okay? They're not always going to be balanced, all right? Now, again, switch cations and anions, making sure the charges add up. So here we have sodium carbonate, right? There's 2 sodiums. What's the charge of individual sodium? +1, because it's alkaline metal. You're going to join that up with the anion from here, which is chlorine, right? What's the charge of the chlorine? It's a halogen. It's -1. You need to remember stuff like that. So it's 1 to 1, right? So there's 2 sodiums, 2 chlorines, so you get 2 NaCl. We'll check the solubility in a moment. Then we're going to take the copper. We're going to put it with the carbonate, right? Again, the positive ion, cation with the negative anion. Cation goes first. What is this charge of this copper? Well, copper's variable, but there's 2 chlorines. This has to be +2. What's the charge in carbonate? You can look on your chart, or you can tell sodium, there's two sodiums, they're +1, carbonate's gotta be -2. So +2, -2, 1 to 1, that's exactly how many there are. And you write out that. Now let's check the solubility, again, looking at the anion. Chlorine, right? Go check your chart, normally soluble. Check the exceptions. Sodium's not one of the exceptions. So this is soluble, so you put aqueous, meaning it dissolved. Copper carbonate, check carbonate. Carbonate is normally insoluble. Check the exceptions. Copper does not fit the exceptions, okay, check on your chart. And so this will precipitate, meaning it will be a solid. So put an S. Okay? I hope I'm making that clear, explaining it so you understand it. Yeah. All right. We're not quite done with this yet. I'll do another example, but I'm going to include something else. We're going to look at another example. We're going to talk about the, let's see here, make sure I got my nomenclature right. What we've been writing is the molecular equation. Next we're going to write the complete ionic equation, and then we're going to write the net ionic equation. And I'll explain what those are here in a moment. Let's first look at an example, and then I'll do those as we go along. Okay, we've been writing the molecular equation. That's what we've been writing. So let's take a look here. We're going to have silver nitrate, aqueous, and we're going to mix that with sodium chloride, aqueous. Okay, again, you're going to switch cations and anions, and then we'll check the solubility, right? So cation, anion. This is +1 because nitrate is -1, that's +1. Chlorine is halogen, it's -1, so 1 to 1. Silver chloride, and then we're going to have sodium. Again, alkaline metal is +1. Nitrate is -1. That's what we're going to get. Let's check the solubility. Go look at chlorine, right? Chlorine's normally soluble, the anion, the chloride ion. Normally soluble. Check the exceptions. One of the exceptions is when it's bonded to silver. So this is insoluble, so put an S. Nitrate, anything bonded to nitrate is soluble. So that's aqueous. Okay? So fine, that's what we just did, right? This is called the molecular equation. Now, in a solution, when you have aqueous, these ions actually come apart. Okay? They actually come apart. Now, how this actually looks in solution is the way we're going to draw it next. This is called the total ionic equation, right? The total ionic equation. Or complete ionic equation. Sorry, some books say total. This one says complete. I'll stick with this book. So next one's going to be the complete ionic equation, which again shows everything as it is in solution. If it's aqueous, it comes apart. So we end up with Ag plus aqueous. This is the way it is floating around in solution. Plus NO3 minus aqueous. Floating around in solution. Again, these have dissolved. Plus sodium plus aqueous. Plus chlorine minus aqueous. And then go over here to the product side. This is a solid. It precipitated, right? So it's not floating around in solution. It did not dissolve. So this stays as silver chloride solid. This, on the other hand, is aqueous, right? So it dissolved. It's floating around in solution. Just like that. This is called the complete ionic equation. Again, as everything is in solution, right? We normally don't write this out. We normally write it that way. But this is how it actually is in solution, right? Now, if we take a look at this reaction, we have here, we have all these ions, and then we come to this side. Well, we only formed one product, right? We formed AgCl, it's a product, okay? I'm gonna write that down. Oh. Let me grab some more chalk. The rest of these are spectator ions on this side. So this formed a product, a solid, right? The rest of these are spectator ions, is what they're called. So we're going to leave those off, and we're only going to write the ions that are necessary to make this up, which is the silver ion plus the chloride anion. This is called your net ionic equation. Okay? That's your net ionic equation. So you might have a problem, in fact I think there's a homework problem, where you go through this whole procedure, right? This is the molecular equation, complete ionic equation as it is in solution, and then net ionic equation. Just showing the one product that formed is what it's doing. Let's take a look at one more example. Excuse me. Let's see what do we got here. All right, well, no, I can do that one. All right, so again, we have lead nitrate plus lithium chloride. We're going to again switch cations, anions, making sure charges match up, right? What's the charge on lead? Well, there's 2 nitrates, so it's got to be 2 plus. We're going to put that with the chlorine, right? What's the charge of the chlorine? It's halogen, so it's -1. But there's 2 of them. So you're going to end up with PbCl2. Plus, then we're going to take, again, the cation with the anion. Cation goes first, okay? What's the charge of lithium? Well, it's attached to chlorine, so it's got to be +1. Plus it's an alkali metal, so it's +1. I'm pointing over there because that's where the periodic table is. So it's +1. What's the charge of nitrate? It's -1. You look at your chart also. And so we're going to have lithium, nitrate, but there's 2 and 2, right? So we end up with that. Now check your solubility. Cl, check chlorine, right? The chloride ion, that's in a soluble chart on the top that you have. And then check the exceptions. Well, Pb is an exception. So this is going to precipitate in a solid. What are we going to get here? Check nitrate. Anything with nitrate is soluble. Okay, there are no exceptions. So that's aqueous. Again, that's the molecular equation. Write the complete ionic. Stop the video, quick write it out, right? I'm assuming you did that. And write the complete ionic. We have Pb, 2 plus aqueous, plus 2 NO3, not NO3, 2. There's 2 NO3s. So 2 NO3 minus aqueous, plus 2 lithium plus aqueous, plus 2 chlorine minus aqueous. Those 2. This stays together, right? It precipitated. This, again, is aqueous, so it came apart. That's the complete ionic. Again, as everything is in solution. Now what about the net ionic? Whoops, I forgot my S. Points off on your test. So now what about the net ionic? Again, you're only going to write something that formed a product. The only thing that formed a permanent product here is the PbCl2 solid. Then we have to write the reactants, the ions that made that up, right? So we're going to have Pb 2 plus aqueous plus 2 Cl minus aqueous goes to PbCl2 solid. Molecular equation, complete ionic equation, net ionic equation, right? Hopefully you got that. I want to point out, it is also possible to have no reaction. Let me write that real quick. Make a quick short example of no reaction in a precipitation reaction. Say we have, let's see here. So we have lithium chloride, which is aqueous, plus sodium nitrate, which is also aqueous, okay? Now we're gonna mix these two together. Again, we're gonna switch cations and anions. Lithium with nitrate, sodium with chlorine, right? Everything plus 1, minus 1, plus 1, minus 1. So everything's 1 to 1. So we're gonna get lithium, nitrate, plus we have sodium, chloride. Check your solubility rules. Anything connected with nitrate is soluble. This is aqueous. NaCl we know is soluble, right? You can check the table, but you'll see that it's soluble, just to be aqueous. So what happened? That's no reaction, okay? You can write down NR for no reaction. You didn't know it's not a precipitation reaction, nothing happened. All these things are just floating around in solution, right? All right, let's take a look at acid-base neutralization reactions. Basically, an acid is a proton donor, okay? An acid is a proton donor, and a base is an OH donor, okay? There's more sophisticated definitions that you would get later on. You won't in this class, but we'll just stick with this for now. So acid-base neutralization reactions. Basically, an acid is a proton donor, right? What's a proton? H plus. Some quick examples, right? HCl, HI, hydrochloric acid, sulfuric acid, nitric acid, etc. Okay? Notice each one of these, right? H in front, proton donor, right? This one will donate 2 protons, right? A base donates a hydroxide, an OH minus, right? So sodium hydroxide, I don't know, lithium hydroxide, I don't know, not magnesium, barium